Hi guys, welcome to my channel on TD Made Easy. To my old subscribers, you're welcome back. And if you're new on this channel, you are welcome. Please click on the subscribe button. In today's video, I'll be teaching you how to draw the intersection of equal cylinders. When we say intersection, that means the interpenetration of two solids. So let's see the example we have. The diagram above shows the intersection of two cylinders with the same diameter. Draw the following. 1. The given view. 2. Complete plan. 3. Line a curve of intersection. And 4. The development of pipe B. Guys, bring out your drawing instruments, your ruler, your pencils, and let's move on to the construction. So the first thing is to draw the given view. So you have to draw the given view as shown, meaning that you have to use the given dimensions. Now you can see for the height you have 70 mm. So you're going to measure 70 by a diameter of 50. 70 by 50. Then you take a height of 10 to the given width. This part may be given to you and it may not be given. The only thing that you will be given that will be the same is the diameter. So you have equal diameter. This is 50 and this is also 50. So you can use any dimension. I left it open so you can use 40, you can use 50, you can use 60, you can use your discretion. So now measure, let's assume we are using 60. Let's assume we're using 16. Okay. So the first thing, bring out your ruler. You measure 70, a height of 70 by 50. Then you take this up by 10. This is 10. This is also 10. 10 plus 10, that gives us 20. 20 from 70, you are left with what? 50. So at an angle of 90, this is just plain. So just measure your 60 and measure this diameter, which is what? 50. So this is 50 and you close it up with 60. A height of 70 by 50. Measure 10 up. Take this side, use 60 and complete it with the diameter, which is 50. After that, you can now draw the center line. The center line is just at the midpoint. If this is 50, the midpoint will be at 25. So at 25, you draw the center line. This is also 50. At 25, you draw the center line. Don't forget that there are two pipes. We have pipe A and pipe B. So that is how to draw the given view. The next thing is to draw the complete plan. When we say complete plan, that means you are drawing not only for one, you are drawing for pipe A and pipe B. So I'm going to start with pipe A. So the first thing you do, just project lines downward. Project lines from pipe A downward. Take this line 1, 2. These lines are projection lines. 3. And move on to the next step. Using the radius of the circle, draw the plan of the cylinder. Remember the plan of the cylinder, when you view the cylinder from the top, you have what? A circle. So that gives us a circle. We already have the diameter. The diameter is what? 50. Now, to get the circle, you pick a radius of 25. Pick a radius of 25 and use it to draw the circle. Okay, the next thing is To draw the plan of pipe B, how do we draw the plan of pipe B? Just project line from this edge downwards. Project line from this edge downward. Also project line from the center of the circle. Take it outward. From the center of the circle, you project a line outward, and from this edge of B, you take it downward. Okay. The next thing is to measure the diameter. The diameter is 50. So for you to get the 50, you measure 25 from the center. Take 25 up and 25 down. That gives the diameter. Because they are equal cylinders, it will end at the tip, at the edge of this circle. So that gives you the complete plan. So let's start from this center line, measure 2.5 up and measure 2.5 down. That gives us the diameter, which is 50. Then close it up with a line down to the edge. Take this one down to this edge. So the next thing is just to outline the plan. We are done. This is the complete plan. When you view this two from the top, let's assume somebody is standing right here at the top. All you will see is a circle and a rectangle. The rectangle will be resting at the edge of the circle. So that is why we have the complete plan looking like this. So we've been able to answer question 1 and 2. Now I want to move on to question 3. Question 3 says we are to draw the curve or line of intersection. When you want to draw the curve or line of intersection, now because you have two equal cylinders, what you will get is a line of intersection because they are equal cylinders and they are meeting at an angle of 90 degrees. But if they are on equal diameter and they are meeting at an angle other than 90 degrees, you have what? A curve of intersection. But because they are of the same diameter, what you will get is a line of intersection. So the first thing you're going to do, from pipe B, project line outwards, the edge. That's the edge. Project from the center line and also project from the third, the last edge. So you are projecting 3 lines, 1, 2, and 3. Then you come to the plan, you do the same, 1, 2, and 3. After you're done with that, you draw a semicircle. Just put a line across using this radius, which is radius 2.5. Draw a semicircle. Same thing you do on the elevation is the same thing you do on the plan. Draw a line which is the same as the diameter 50. Take a radius of 2.5 and draw a semicircle. So the next thing is just to divide the semicircle into 6 equal parts. If you don't know how to divide into 6 equal parts, you can check my videos on division of a circle into 6, 12, and 8 equal parts. So you divide this into 6 equal parts. So I have 1, 2, 3, 1, 2, 3. You do the same thing on the plan. 1, 2, 3, 1, 2, 3. So I have 6 divisions on the elevation and I have 6 on the plan. It is 6 because we are using semicircle. Okay, the next thing is to project line from the divisions. So you come to the first division, draw horizontal line. These lines you are using construction line, which are thin lines. Project lines inward, project lines inward, go to the divisions and project lines, horizontal lines, so you can move your T-square to get these lines accurately. After the projection, you number your divisions. Now, in intersection or interpenetration of solids, there's a way we number. So look at this numbering: 1, 2, 3, 4. When you get to this height, this point, you descend. This is from 4, you go back to 3, 2, 1. Let me start again. 1, 2, 3, 4. When you get to this highest point, you descend to 3, 2, 1. That is on the elevation. Now, when you get to the plan, you start from the highest point that you use on the elevation, which is 4. So from 4, you move on to 3, 2, 1. Then you go back to 2, 3, 4. The reason why we're doing this is that when you move your line so that it can intersect and give you the correct answer, there's a switch. So that's the reason why we are changing the numbering when you get to plan. Let me give you another example. You may start with A, B, C, D. When you get to D, you go back to C, B, A. Now, when you get to the plan, you start with D, C, B, A, B, C, D. So that is how to number in intersection. So now the next thing is just to get our line of intersection. To get the line of intersection, you need to be very careful because you are to draw projection lines from the plan to the elevation. So you come to the plan, you start from the first line, which is number 4. Look at number 4. So you trace 4 from the semicircle, you trace it down to the point where it's touching pipe A. So now it's touching it at this point. This is A and this is B. This is A and this is B. So it's touching it at this point. Then from this point, you draw a vertical line. In this case, you don't need to draw a vertical line because the center line will serve as the vertical line. You project it up to the point where it will intersect with number 4 on the elevation. This is line 4 on the elevation coming this way to meet with line 4 on the plan. This is line 4 on the plan and line 4 on the elevation. So we are meeting at this point. You are steric. I'll move from there. I'll come to number 3. Trace number 3 to the point where the horizontal line is touching the circle. See, it's not exceeding. So the point where it's touching, you draw a perpendicular line up and you let it intersect with 3 on the elevation. So 3 on the elevation, then this is the second one, 3 on the elevation. From there, I move on to 2. I'll trace 2 from the semicircle down to the point where 2 is touching the circle. Draw a perpendicular line, intersect with 2 on the elevation, 2 on the elevation. From there, I'll move on to the last one. The last one is just line 1. And line 1, we move with the edge. We move with the edge. So asterisk and asterisk. So after that, the next thing is just to draw the line of intersection. So from there, just join it together with a straight line. This line gives the line of intersection. So from there, we are moving on to the development. The last question says development of pipe B. So how do we develop pipe B? Now, because our focus is on pipe B, let me trace pipe B. Pipe B includes the line of intersection. So this green line plus this black lines make up pipe B. Now, pipe B is a cylinder and is a circular object. So when you want to develop, it means you want to unfold. You have this, you want to unfold it, meaning that you want to open it up. You want to unfold from a 3D to a 2-dimensional object. So now, the first thing to do, project lines from the line of intersection. These are the lines of intersection. I'll project this line downward. I'll project, so this is from 4. Take 4 downward, project 3 downward. I cut out my plan because of my drawing space. So I removed the plan. So you project 2 downward, project 3 downward, project 1 downward. Then you also project the edge. You take it downward. From there, the next thing to do is just to divide your space into 12 equal parts. I'm dividing into 12 because it's a circular solid. And this is what already we have 6 divisions here. So when you open it into, and when you unfold it, you have 6 times 2. That gives us 12. So from here, from this division, all you need to do, just leave a little space from this elevation, leave a little space as your starting point. Something like this. Just leave a little space from this to this. So this is your starting point. Then you mark off 12 equal divisions. How do you mark off? Just take any of the equal divisions. You can take 1 to 2. You can take the radius of 1 to 2, or 2 to 3, or 3 to 4. Just pick any. Center here. Center here. Mark off 12 equal divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 equal divisions. Don't forget, I am starting my numbering from 1. I will start from 1 and I will end at 1. I'm starting from 1 and I'm ending at 1 because 1 is a seam. A seam is a joint. It's just like opening a cylinder. The point at which you are opening is the same point where you will close it up. So I'm starting with 1 and I will end with 1. So then how do I number my division lines? Follow the step. You can use another step, but this one is very easy to follow. So since I have 1 to 4, I am using the same thing. So I have 1, 2, 3, 4, 3, 2, 1. 2, 3, 4, 3, 2, 1. So this is my numbering. So after the numbering, the next thing is just to asterisk and get the points of intersection. So let me asterisk from here. So this is what you need to do. So you look at point 1, trace 1 on the division and go to the line of intersection. This is line 1. So 1 is meeting 1 at this point. So you asterisk it. You asterisk this point. Come here. 1 is meeting 1. So we asterisk. Okay, I'll leave there. I'll go to 2. You trace 2. 2 is meeting at this point. 2 is meeting at this point. You asterisk. From 2, you move on to 3. Trace 3 from the line of intersection where it's meeting 3 on the division line. You put your asterisk. The next one is 4. Trace line 4 from the line of intersection. You asterisk it is meeting 4 at this point. 4 is meeting at this point. You asterisk. So you continue to trace. After 4, you descend back to 3. After 3, you come to 2, you come to 1. You take it back to 2, 3, 4, 3, 2, 1 until you get to the last point. So when you are done with that, all you need to do, you outline with a curve. Outline with a curve. Please retain these lines as construction lines. Leave them as construction lines, and you outline the edge of the cylinder of the development. Outline it. but use your French curve to get a smooth curve for this part because it's still a curve or circular object. So you have to use curve to join these points. So this is how to develop a cylinder.